This is a lecture on advanced functions. The topic is rational function and its application. This is from the textbook McGraw-Hill-Ryerson, Advanced Functions, Grade 12, Section 3.5. So usually there are two types of problems. One type is that the problem doesn't give you the function, but from the descriptions of the problem, you need to find the function on your own. And this is the example I'm going to show you. The example is this. Sound intensity varies inversely as the square of the distance between the listener and the sound source. So this is the description of the function. So you are required to find the function. And given a condition that the sound intensity is 0.001 watts per meter square when the distance is 2 meters. So you want to find the function, and you also want to graph it. The next part is, what is the intensity if the distance is halved? Now the given condition is when the distance is 2 meters, the intensity is 0.001. But now this part is asking you when the distance is 1 meter, what is the intensity? Okay, this is how you do it. So from the wordings, the intensity varies inversely as the square of the distance. This means the intensity I varies proportional inversely. Inversely means 1 over something. The question tells us as the square of the distance. Now, let's call the distance d, then the square of the distance is d squared. And because it varies inversely, the relation is 1 over d squared. So I varies inversely as the square of the distance. The next step, we need to change the proportion label into equal sign. The way you do it is to change this to equal sign and put a constant k on top. This is how you write it. Intensity is equal to constant divided by distance squared. Once I have this function, then I can use the conditions that here. This is a condition. When distance is 2 meters, the intensity is 0.001. So I put 2 meters there. Here, look here. I put the distance equal 2 meters, and the intensity is 0.001. From this, I can find k. 2 squared is 4, therefore k is 4 times 0.001, which gives you 0.004. Now I have the constant k. Put the constant back into the equation, into this equation, I equals k divided by d squared. Put k into it, and then I have the function I equals 0.004 divided by d squared. Now this is the function we want to find. Once I have this, the next part is very easy. The next part is asking us what the intensity is if the d is 1 meter. So you just replace d by 1 meter. I is equal to 0.004 divided by 1 meter squared, which gives you 0.004. If the distance is halved, so originally the distance is 2 meters, but now I have 1 meter. Look at the intensity. When the distance is 2 meters, intensity is 0.001. When the distance is halved, it's 1 meter, then the intensity is 0.004. What can we conclude from this? If the distance is halved, the sound is 4 times as intense. So this is the meaning of inverse. Inverse variation. Inverse means if the distance is smaller, the sound intensity becomes bigger. Or you can say, if the distance is larger, then the sound intensity will be smaller. So this is called inverse relation. Okay. Once we have the function, which is this is a function, we can graph it. Now look at it. It is 1 over distance squared. So if you use the table values, you will get a graph. This is a graph when you use the table values. So this is a graph. When the distance becomes larger, the sound intensity drops. That's inverse relationship. Okay, but this is not inverse to the distance. It's inverse to the distance squared. So the curve looks like this. Now this is an example where the function is not given, but the question describes the relation between the two variables, the intensity and the distance. And from the description, we need to find the function. So the next type of the problem is that the function is given to you. Instead of asking you to find it, the function is given to you. Let's look at the second example. The second example, the function is given. This is a function. What is the question? The question is this. You have a store. This store sells coffee. The profit, of course, depends on how much coffee you sold. And the function is given to you. The profit is equal to this divided by this. And where the x is how many kilograms of coffee you sell. So this is the amount of coffee, and P is the profit. Look at this function now. If we let the numerator be 0, you will find the X-intercept. So when this is 0, what is the X-intercept? The X-intercept is 50. Yeah. You let this be 0, X-intercept is 50. Let's see now. Where did I put it? Yeah, here. You let the numerator be 0, and the X-intercept is found to be 50, right? How about the Y-intercept? You let x equals 0. The Y-intercept is negative 200 divided by positive 400. So the Y-intercept is negative 1/2. The vertical asymptote can be found by letting the denominator equal to 0. So we let x plus 400 equal to 0, then what is x? Then the vertical asymptote, the denominator equals 0 is y equals 4. Oh no, wait a minute. X equals negative 400. That's a vertical asymptote. What about the horizontal asymptote? The horizontal asymptote is just this coefficient 4 divided by this coefficient, which is 1. So it's 4 over 1. That gives you the horizontal asymptote. And the equation of the horizontal asymptote is y equals 4. And then you can graph this function using a number line. So on this number line, you put down the x-intercept, you put down the vertical asymptote, and then you label which interval is plus, which interval is minus. That's a method we introduced before this lecture. And if we do that, we can draw the graph very easily. Okay. We talked about the x-intercept. X-intercept is 50. So x-intercept will make the numerator 0, which means the x-intercept means the value of x which will make p 0. That is, the x-intercept means the profit is 0. When x is less than 50, if you put a number into here, less than 50, you will find the p is negative. What does that mean? That means you do not have a profit. Instead of profit, you have a loss. When the x is larger than 50, you put a number larger than 50 there. This is positive. Then you have a profit. Okay. So that is the discussion of the profit function. So next, we are talking about average profit. What is average profit? What is the meaning of average profit? The meaning is that if you divide the profit by the value of x, the result is called average profit. What is the meaning of that? That is the profit per 1 kilogram of coffee sold. All right? Profit per 1 kilogram. That is called average profit. So let's do that. Let's divide p by x, and then this should be the result. P divided by x. You have an extra x in the denominator. Let's find out what kind of graph this is. So the x-intercept is the same because the numerator is the same. So you let numerator equal to 0, you find the x-intercept, which is 50, same as before. But now the denominator is different. So how about the y-intercept? Y-intercept is the denominator equals 0. Then you have x equals 0. That's one vertical asymptote. And x equals negative 400. That is another vertical asymptote. The y-intercept is when you let x equals 0. But when x is 0, your denominator is 0, which is not possible. When denominator is 0, you don't have any, this p, average p is undefined. So you do not have a y-intercept. And then, what's the next step to graph the function? The next step is to draw a number line. And you put down the x-intercept and put down the two vertical asymptotes. And then after that, you label the number line with plus sign and minus sign for the various intervals. So if you do that, then you get the then you can sketch a rough sketch of the graph. Okay, here is the graph of the profit function. How do we get that? So we have this. The x-intercept is 50. The y-intercept is -1/2. For the other points, we have to do table values. So I did table values, and I got these open circles, and joined with a smooth curve. That is a profit function. Now how about the average profit? So we have the x-intercept and the vertical asymptote, two vertical asymptotes, and we have the intervals plus, minus, and so on. So we can sketch the graph. And again, we need to do some table values. The result is the next graph on the next page. This is a profit function, average profit function. So you see the intercept is still 50, but there is no vertical asymptote. There is a vertical asymptote, x equals 0, which is the y-axis. And there is another vertical asymptote, which is x equals -400, which is not shown here. Because x is the cell, you don't need to consider the negative value of the cell. The cell is always positive. So you only need a graph on the positive side of the x-axis. And if you do point by point using table values, you get a graph like that. The graph shows us there is a maximum point here. How do we find the maximum point? There is no accurate way in advanced functions. If you draw the graph using table values, you will find the approximate location of the maximum point. If you want an accurate location of the maximum point, you have to use calculus. Yeah, but this is beyond the scope of the advanced functions, so we will not discuss that. I forgot to mention that for the profit function, you also graph this only for the positive x-axis, because the cell has to be positive. There is no negative cell. Okay, that's it for today's lecture. I'll see you next time. Thank you for watching. Bye-bye.